The title of his talk is Radio Spectrum Awareness Using AI for Reliable, Efficient, and Secure Wireless Networks. Yu-Dong Yao.
Yes, thank you, Harry, and hi, everybody. And what I want to present is about the radio spectrum awareness using the AI, and it's the subject area of wireless communication, electrical engineering, and specifically for reliable, efficient, and secure wireless communications. And very quick to explain what's radio spectrum awareness and why we want to do it, right? Radio spectrum awareness, just like we are very, common now, everybody use every day, either Wi-Fi or you use a cellular phone. So that's a wireless transmission. We need a certain bandwidth, the frequency band to transmit the signal, receive signal. And then, so the research is about, we want to know what's going on in the radio spectrum. And typically, easy example would be any jamming, any intruder jamming signal, and then how many, what's the bandwidth availability in that channel. So yeah, we want to know what's going on in the spectrum, and then we want to know it because for the better operation, efficiency, and security, reliability. So that's about the radio spectrum awareness. An example, for example, is like reliability, the better receiving quality. In that regard, we want to know the what's the channel information, channel statistics. So for the new system, for example, massive MIMO system design, we need that information. Reliability and efficiency can be trade-off. So therefore efficiency, similarly, we can have better utilization, high throughput, and better reception quality. So for the channel receiver design. And then the other thing, certainly for security. For security, as I say, the intruder detection, jamming signal detection, like those type of things. Anyhow, so in the domain of spectrum awareness, we able to use AI to achieve those goals. All those are the related publication we had in recent years. We started with the machine learning approach very early on. Use machine learning to understand the channel and the cellular handoff, and then transmission protocol. That's the time we use the traditional machine learning algorithm. Recent years start to use deep learning algorithm. Okay, I give some specific example. So-called spectrum awareness, we want to know what's going on in the channel environment, right? So for this case, there is certain channel model. It's one of the model is called the rising fading channel. And then it's, of course, it's a random process, statistics. There's a parameter called K factor. So there's the issue of how do we estimate the K factor value so that we can design or operate running the system, right, accordingly. So that's where we do the deep learning gets involved. For example, in this case, this shows the waveform, signal waveform received, signal waveform received. And then, of course, there's certain data size, what's the data size for training, validation, testing, right? And then the whole neural network for the deep learning, AI deep learning. The purpose, the use of this approach is to identify, in this particular example, we have 3 classes. If it's a K equal to 0, that's actually one of the very severe fading environment, really fading, or you have a line of sight, K equal to 1, or very, very strong line of sight, K equal to 10. So that's where we use and how we use the deep learning for channel estimation to understand the channel. So that's part of the spectrum awareness. And again, so for our work is like this. What we do is, basic the deep learning architecture, maybe some modification and a slight change of parameter, right? And the issue is address this issue, identify the channel in terms of K factor. And then how do we pre-process the data? Because we get the data in application would be capture the data over the air, radio receiver. But for the experiments initial evaluation, student run MATLAB to generate the signal with different type of signals, right? Certainly. So that's the waveform we receive at a given time window, and the given time window we receive, and then process it. Because all the signal generated, it's labeled because we generated the signal, so it's kind of labeled. So use that to do the training. And then through the learning process, typically we use the transfer learning. If we use existing model, then we are able to classify and then to examine the classification accuracy. Okay, so that's the point, is how do we use deep learning to identify this? And then for this, for example, this is the issue about channel or signal phase offset estimation. This again relates to the channel estimation or relates to the device feature, device quality, right? And then if you can see here, for this case, we have certain data, right? This will be one of the transmission scheme called the QPSK. And then in the normal high quality channel and high quality device, so that might be the constellation. And then this would be certain phase offset. This is more severe phase offset. Again, this is the deep learning structure. And then those will be the data with the label, because we generate, we transmit, we receive, right? So we would know. And then what we want to get out is the phase noise, if 0 degree, 20 degree, 35 degree. But anyhow, so this is the example, talk about the understand the device, because the phase distortion could be in the channel or in the device. So that's another work. So this is type of spectrum awareness. Okay, and then one more example, and just like right now, we have 5G. We start to use 5G signal, right? 5G systems operation. So this is so-called 5G signal identification. So basically the environment right now, there's an old system, new system, compatibility, environment, mutual interference. And then, we agreed already very early on, we want to have full understanding of the spectrum awareness. Okay, so that's a different signal model, like 3G UMTS, 4G we are using right now, LTE, and then we'll be use this one very soon, everybody, 5G new radio. And then we capture a signal, and then to see the signal waveform, we could observe from time domain all the transformation and the pre-processing the data, spectrogram, anyhow. So use this, go through the deep learning model, we identify the thing. So that's another example. In conclusion, basically we use the AI deep learning for our application. So the specific thing what we do, right? Do what? We identify problem applications. We need to formulate the problem. So basically for the data pre-processing, then we use a deep learning model and then get the performance results. This would be how well we know the spectrum. Okay, everybody. So that's a talk and 8 minutes. Thank you, everybody.
Okay, thanks, Yu-Dong. I don't see any questions submitted in the Q&A box. Let me try to ask one anyway. Everybody's talking about the 5G networks, right?
Yeah.
That appears to be the future, but what is the future after this 5G future?
Oh, well, 5G future started already. Now there's a workshop, research paper about the 6G.
I see. So what's the differentiating feature in the 6G versus 5G?
Yeah, typically it's always the performance improvement, just like I said early on. The reliability, throughput, efficiency, and the security, right? So, which means more reliable, high throughput, and which means the data rate, and also inherent security, and also now realize the importance of AI. So AI, like what we are doing now is AI afterthought. We have the 5G, 4G already. We do some AI, But in the future, design would be AI part of the design of the 6G.